All right, so today we're going to be talking about putting things or solving and graphing things in the intercept form. Graphing parabolas in the intercept form. So intercept form looks like this, where we basically have the factored form of our quadratic. Okay? This form is nice because it's very easy to determine your x-intercepts, which is one of the things we're finding today. We're finding our vertex, axis symmetry, and our x-intercepts. Okay, so there's three things we need to find: our x-intercepts, our axis of symmetry, and our vertex. Okay, so first things first, to find the x-intercepts, it's pretty simple. When we have it all factored like this, we're just setting these individual parentheses equal to 0 to find our x-intercept. So if I have x minus 1 is equal to 0, to solve that I would add 1, right? So the x-intercept would be at 1, or 1 comma 0. So one of my intercepts is going to be at 1 comma 0. The other one, x plus 3 equals 0, you'd minus 3, it would be negative 3, 0. So there's my two intercepts right there, negative or 1, 0 and negative 3, 0. So I'm just going to put points there right now. 1, 0 and negative 3, 0. Now the axis of symmetry, to find that you take your intercepts, add them together, divide them by 2, right? So I would be adding 1 and negative 3 together, which is negative 2. Divide that by 2, I get negative 1, right? So right here is my axis of symmetry. Again, you don't have to add them together and divide by 2. You could also just go meet in the middle. It's halfway between your intercepts. If this is a parabola, that means that every point in a parabola is equidistant away if they're going to be symmetrical. So if this is 4 spots away from that, then I would go halfway. So that would be at negative 1. Okay? So I know the vertex, I know the axis of symmetry is going to be x equals negative 1. And I know the vertex is going to be at negative 1. And then, to figure out the y value, I plug it in. So negative 1 in for both of these. So negative 1 minus 1 is negative 2. Negative 1 plus 3 is 2. Multiply those together, you get negative 4. So the y value would equal negative 4. So down here at negative 4 is my vertex. I know that my parabola is going to look something like this. Okay? And really, that's all you're doing with the intercepts. However, let's look at some other examples here. So if we look at this one, x minus 2 squared. I could write this as x minus 2 times x minus 2. But when I solve it, I would get x is equal to 2 both times, right? That's because in this situation, there is only one x-intercept. The x-intercept is going to be 2 comma 0. So 2, so the x-intercept is 2 comma 0. Now, if that is the x-intercept and there's only one, that also tells me so many things. It tells me that it is also going to be the vertex. Because if it intercepts the x-axis only once, that means it is starting at the x-axis. Otherwise, there would be 2 or none at all. So that means the vertex also has to be 2 comma 0. That also tells me the line of symmetry, or the axis of symmetry. I've been writing axis the whole time. Axis would also be at 2 on the x-axis, right? So x equals 2. So right here is the line of symmetry. This is my vertex. And then if I want to figure out some points, I've got to plug some points in here. So I know the axis of symmetry, I know the vertex. If I do my table, I would have, 5 values. I've got 2 and 0 is my vertex, and then 1, 0, and 3, 4. If I plug in 0, 0 minus 2 is negative 2. Negative 2 squared is 4, and I would get negative 4. If I plug in 1, 1 minus 2 is negative 1. Negative 1 squared is 1, and get negative 1. And then because it's symmetrical, I know 3 is going to be negative 1, and 4 is going to be negative 4. So then I can plot those points. At 1, it's negative 1. At 0, it's negative 4. 3, it is negative 1. And 4, it's negative 4. And that gives me my parabola. And that is how you graph in intercept form. Another one you might be confused. Oh, lights just went out. Hello. There we go. Great. Another one you might be confused is this one. This would just be like x plus 0 as like in parentheses, which means x, when you set it equal to 0, x is just going to equal 0. So it is starting right there at the origin with its vertex, and then you're figuring out where it's going from there. Okay, and that is the intercept form.